In this video, we're going to discuss how to find the average value of a function, the mean value theorem for definite integrals, and also look at some example problems involving these two topics. If the function f is integrable on a closed interval ab, then its average value on that interval is 1 over b minus a multiplied by the integral from a to b of f of x dx. The mean value theorem for definite integrals is the following. If a function f is continuous on a closed interval ab, then at some point c on the interval from a to b, f of c is equal to the average value of the function. So that is, f of c must be equal to 1 over b minus a times the integral from a to b of f of x dx. This is basically saying that somewhere on the interval from a to b, if you take the functional output at that value c, you're going to get the average value of the function. Let's take a look at some examples of this. Suppose we want to find the average value of this function y equals 4 times the sine of 0.5x plus 1 minus 1 on the interval from negative pi to 2 pi. So basically what we're doing here, let's suppose that you could take all of the possible functional outputs of this function and add them all up and divide by the number that there are. You would get the average value. Now unfortunately, because there's infinitely many outputs and there's also infinitely many inputs, we can't divide an infinite number of things by an infinite number of things. The reason why we have an integral here is because the integral is representative of a limit of Riemann sums. That is, a limit of the heights of rectangles, heights being functional outputs. So you're taking a bunch of functional outputs, expressing that limit as it goes to infinity, and so you have infinitely many functional outputs. So in essence, that's why this works. All you really need to worry about, though, if you're not interested in the details, is to be able to apply the formula. The formula being, take the lower bound of the interval and the upper bound of the interval, and those are your bounds for your integral, and then take the function and integrate it from negative pi to 2 pi. We're then going to take that integral and multiply it by 1 over the upper bound minus the lower bound, or in this particular case, 1 over 2 pi minus negative pi, or 1 over 3 pi. When evaluating the integral on the calculator, we get that it's about 1.6294. Taking this then and multiplying it by 1 over 3 pi, or dividing it by 3 pi, we get that the average value is about 0.1729. For the next part of this example, we're going to actually find the c value that satisfies the mean value theorem. In other words, the specific input that will give us an output of 0.1729. This boils down to the following equation: 4 times the sine of 0.5c plus 1 minus 1 equal to 0.1729. You could solve this algebraically and using trigonometry, but I'm going to take the easy way out and use the calculator. I put both of my sides of my equation in for y1 and y2 respectively. I set my window up to only accommodate from negative pi to 2 pi. Using the calc intersect feature, I find that the first x value, or c in this case, is about negative 1.4048. And I find that the other c value is 3.6879, so about 3.6880. For the final part of this problem, I'm going to draw a sketch of the graph that has the same area as the integral that was asked for at the beginning of the problem. And by area in this case, I mean net area, in other words, the actual value of the integral. Recall that the value of the integral that we found earlier was 1.629. Recall that the average value that we found was about 0.1729. If you draw a rectangle that has a height of 0.1729 and multiply it by width of 3 pi, you'll get exactly 0.1629.